Hi there. We're going to go through the solutions to the UK Maths Trust Intermediate Maths Challenge that was held on the 6th of February 2020. Firstly, with question 1. Okay, I find it helpful always to write out the question. I know a lot of these you can probably do in your head. But if we have 2 subtract, we're going to do what's in the brackets first. 3 subtract 4 gives us -1. And then again, I'm going to do the operation within the brackets, which gives me 5 subtract 6 is -1, subtract 7 gives me -8. I have 2 subtract -1 gives me 3. And then 3 subtract -8 is going to give me 3 plus 8 or 11. So the answer to question 1 is A. Question 2. Which one of these is a multiple of 24? I don't know my 24 times table, so I'm maybe going to have a look at the factors of 24. Maybe I could work out the prime factors. See if that helps. Helps to a point, because if we know that it's in the 3 times table, then we know that the digits have to sum to 3 or a multiple of 3. So that eliminates anything where the numbers don't sum to a multiple of 3. So we've now got a choice of 300 or 600. Obviously my 2's don't help me, so let's have a look at the 8 and we can see if 300 or 600 are multiples of 8. So if I start with 300 first, quick bit of short division gives me 8 goes into 33 times, remainder 6, 8 goes into 6, and we can see straight away that it can't be 300. I now just quickly want to double check, make sure I've got the right answer. I can probably see now if I've got a remainder 4 and I'm doubling my 300 to 16, that would now be a remainder 8, and obviously the number we're dividing by is 8, but let's just double check. Okay, 8 7s are 56, remainder 4, and 8 multiplied by 5 gives us 40. So the answer to question 2 is E. Question 3. As I say, really helpful to write the question out. First, I've got 25% of £37. I've got 25% of £17. I want to work this out as quickly as possible. I'm trying to find the difference. So the difference between £37 and £17 is £20, and 25% of £20 is going to give me £5. So 25% of 20, or 20 divided by 4, gives me £5. The answer to question 3 is B. Let's move on to question 4. Now, we can just simply count the shaded squares here. What I could do, because I know that I'm looking for a fraction, I could just look at half of it because it's equal on both sides. So if I simply add these together, 1, 2, 3, these 2 halves are going to make 4, and these 2 make 5. So I've got 5 shaded squares out of 8 in total. So my answer is 5/8. Obviously, if I'd done the whole shape, I would have ended up with 10 over 16, which I could have then simplified back down to 5/8. So the answer to question 4 is 5/8 or D. Question 5. Now, the way I did this one, I just wanted to keep it really simple. So I figured the quickest thing for me to do was to actually just sketch it out really quickly. 1, 2, 3, 4, and 1 gives me A. 2 up 4 gives me B. 5, 6, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6 gives me C. D is 1, 2, 3, 1, 2, 3, 4, 5. So D. I could probably see just by looking at it that D was an anomaly. Finally, E. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. And then I can just quickly join those together. I can see, can't I, that that makes my square. I can see that D is my odd one out. We don't have to do anything fabulously mathematical. If it's quicker to draw it, it's entirely up to you. If you do want to look at it mathematically, then we would want to be looking at these side lengths here. So for example, A to B, we've got our coordinates here. A to B would be 2 squared, the difference between 4 and 2, plus 3 squared, the difference between 1 and 3, square rooted. That would give us root 13. And I'd just keep going. AC is 1 squared plus 5 squared, square rooted, which gives me the square root of 26. AD, 1 squared plus 4 squared, giving me the square root of 17. Keep going. AE, can you see that okay, would be 3 squared and 2 squared, so 9 plus 4 gives me the root of 13. So I can see now I've got a pattern developing. I need to keep going. BC again would be 3 squared plus 2 squared. That's giving me my root 13. And then if I just do one more, 1 squared plus 1 squared in this case is just going to give me the square root of 4, which is 2. So as you build up a pattern, you start to see that D is the odd one out if you calculate it this way, or as I say, just having a look at it, either sketching it out or just looking at the differences between the X and the Y coordinates means that you can probably just see it intuitively. So the answer to question, just put my pen down, the answer to question 5 is, of course, 3, 5 being the odd one out, which is D. Question 6. Question 6, I've written it out quickly. 2 to the power 6. You probably know most of these off by heart anyway, but 2 to the power 6 gives us 64. 3 to the power 3, I've got 9, 27, 81, 243. I've got 4, 16, 64, 256, 5, 25, 125, and obviously 36 as my last one. So I can see therefore that 4 to the power 4 is the largest value. The answer to question 6 is C. Question 7. All right, we are told that there are 10 possible finished grids. And we want to see how many of the finished grids have 2 red squares next to each other. So I don't have the right colour pens here, rather annoyingly. So we'll just improvise. Oh, actually, maybe I do. No, I don't. Okay, so anyway, so we've got a combination where we've got 3 blue and 2 red. All right, we've got 2 red together here, 2 red together here, 2 red together here. And to be honest, I didn't need to draw the other 6 configurations. They're not relevant, they don't help me, because there's no other way I can have 2 red grids, red squares together. So I have 4 potential solutions. To the answer to question 7 is B and 4. Question 8. Now, I don't have time to work out 17 squared, 19 squared, 23 squared, and 29 squared. So I'm just going to focus on the last digit. If I look at 17 squared, I know that 7 squared is 49. So I'm just going to look at the unit. just going to look at the 9. 19 squared. I know that 9 squared is 81. I'm just going to look at the digit that will go in my ones column. The same with 23 squared. 3 squared equals 9. So I'm going to have a 9 in the ones column. And finally, 29 squared is going to give me 9 squared being 81. I'm going to have a 1 in the ones column. If I add them together, I'm going to get 20. I therefore have 0 in the ones column. There is only one answer that has a 0 in the ones column. So the answer to question 8 is E. Question 9. Right, so if Adam's house can only fall in exactly one of those ranges, I'm going to quickly sketch it out. I'm sure you don't need to. I'm sure you can just look at this and see straight away that for A, it's going to go from 1, 2, 3 to 2, 1, 3. For B, it starts a little bit higher. It goes from 1, 3, 2 up to 2, 3, 1. So it goes a little bit higher as well to 2, 3, 1. C starts at 1, 2, 3, so it starts at the same point as A, and it goes up to 3, 1, 2, so it goes up here somewhere. It does not obviously have to be to scale. Now let's look at D, 2, 3, 1, so it starts up here, and it goes to 3, 1, 2, 2, 3, 1 to 3, 1, 2. Finally, when we look at E, it doesn't start until we get to 3, 1, 2. And it goes to 3, 2, 1. So E is the only one that is on its own. Okay, so the answer to question 9 is E. And as I say, I'm sure you didn't need to draw it out like that to get the correct answer there. Question 10. Always find it helpful to write out the question. First, it gives me a little bit of thinking time. I've got 2,468 lots of 2,468. But here, I've only got 2 lots of 2,468. So let's write that again. 2,468 multiplied by 2,468 over 2 lots of 2,468. I know that I can cancel out. 2,468 divided by 2,468 is going to give me 1. So I'm simply going to be left with 2,468 divided by 2, which is 1, 2, 3, 4. So the answer to question 10 is B, 1,234. Question 11. Right, there's a couple of different ways of looking at this. I'm going to show you the sort of the longer way to start with. So bear with me while I draw it out. So we start with 1. From 1, I have a choice of going to either 2 or 3. From 2, I have the choice of going to either 3 or 4. And from 3, I have the chance or the choice of going to 4 or 5. From 3, I can go to either 4 or 5. From 4, I can go to 5 or 6. From 4, obviously 5 or 6. I think I'm going to need a smaller pen, and I can go to 6 or 7. Let's keep going. I'm just going to use a slightly smaller pen so you can see. Right, so I'm up here. From 4, I can go to 5 or 6. From 5, I can go to 6. You get the idea. 5, I can go to 6 or 7. From 6, I can only go to 7. From this 5, I can go to 6 or 7. This 6, I can only go to 7. This 6, I can only go to 7. And obviously, I've stopped here. Right, let's keep going. From this 5, I can go to 6 or 7. This one, I can only go to 7. Only go to 7. Only go to 7. You get the idea. So if we count all those up, you'll see I have 13 different ways of getting from 1 to 7. So there's 13 different solutions. But I just want to quickly explain how else we could have got to that solution. So if I look here, just at my little grid, to get to 2, there's only one way I can get to 2. I can only get to 2 from 1, and obviously 1 is where I start. From 3, there are 2 different ways I can get there. I can get there coming from 2, or I can get there coming from 1. So I have 2 different ways of getting to 3. To get to 4, 1, 2, 4, 1, 3, 4, or 1, 2, 3, 4. So there are 3 different ways of getting to 4. To get to 5, I can do 1, 2, 3, 4, 5, 1, 3, 5, 1, 2, 4, 5, 1, 2, 3, 5, 1, 3, 4, 5. So there are 5 different ways of getting there, and so on. When you work out the different ways of getting to 6, there are 8 ways. And when you work out all the different ways of getting to 7, there are 13 ways. So what you might notice here is we are developing the Fibonacci sequence. If you can see that, then obviously that is a much quicker way to get to the solution of 13 rather than writing them all out individually. I missed 1 7 out there, so apologies. There is, I just counted them up and I got 12, so I've just double checked and that was my 13th. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 different ways. Just wanted to double check it was correct. Question 12. So we have chickens and goats. Let's have a look. So 80 animals were sold. So the number of chickens and the number of goats that were sold was 80. So that's the number of animals that were sold. If we look at the legs, we know that a chicken has 2 legs. So for every chicken that we sold, we lost 2 legs. And for every goat that we sold, we lost 4 legs. And there are 200 fewer legs. I've now got 2 equations. So let's take a look and see what I can do. Let's rewrite it. So if I just simplify this, divide by 2, I'm going to have C plus 2G equals 100. I know from my first line that C plus G equals 80. So if I subtract, C subtract C cancels out, 2G subtract G just gives me the number of goats. 100 subtract 80 gives me 20. So the total number of goats is 20. The answer to question 12 is B. Question 13. Half of 1.6, so 1.6 times 10 to the power 6. If I halve it, half of 1.6 is 0.8 times 10 to the power 6. That's now not in standard form. So to change it into standard form, I need to write it as 8 times 10 to the power 5. If you're not quite sure on how to do that, it takes a bit of time, but there's nothing to stop you simply writing it out. You don't even need to write them all out. It can just be representative. But 1.6 times 10 to the power 6, so times 10 6 times, is the same as 16, because 1.6 times 10 gives me 16, is now going to be times 10 to the power 5. And then when I divide it by 2, I'm going to have 8, but I'm going to still have 10 to the power 5. 8 times 10 to the power 5. So the answer is C. Question 13, 8 times 10 to the power 5. Question 14. Now we need to remember some of our facts here. We talked earlier on about the fact that if a number is a multiple of 3, then if I add the digits together and they sum to a multiple of 3, then that number is in the 3 times table. Now exactly the same applies to the 9 times table. So because I know that this calculation here is a multiple of 9, I know that if I sum these digits together, 3 plus 8 plus 1 plus 8 plus 5, that's going to tell me what number I need n to be to create a multiple of 9. So if I add these together, 3 plus 8 is 11, 12, 20, 25. So to get to 27, I've got to add 2, because 27 is a multiple of 9, and therefore the number 328,185 is a multiple of 9. So the answer to question 14 is A2. Question 15. So I'm told that this large triangle here has been divided into 25 congruent right-angled triangles. So we know that all of these are right angles. We know that the length RP is 2.4. We know that if that is a right angle and this is a right angle, then the sum of these two angles here is also 90 degrees. Now I'm just going to take, now if you've got a paper in front of you, you can just turn this around if you find it's easier to make your right angle either here at the bottom left or here at the bottom right. But I'm just going to draw it out again quickly. And I'm going to, just because I think sometimes if you have the right angle at the bottom, it makes it a little bit easier to visualize. So let's use the same notation. So this is now Q, this is now R, and this is now P. So I've just rotated it round. I know that RP is 2.4 because it's 4, well, I'm told it's 2.4. I know that that 2.4 is 4 small congruent triangles. So that means each individual hypotenuse of these small congruent triangles is 2.4 divided by 4. So that tells me that that distance there is 0.6. Now, if I look down this side, I have 3 hypotenuse. So I have 3 lots of 0.6 is going to give me 1.8. Just write that for completeness. So that tells me that this distance here from R to Q is 1.8. R to Q is 1.8. So now I need to work out, the question is, what's the length PQ? That is my hypotenuse. I can see clearly that that's my hypotenuse now. And I know that 1.8 squared plus 2.4 squared square rooted is going to give me my hypotenuse. But those aren't very nice numbers. Let's see if there's anything we can do with them to make them easier. Remembering that when we're working with similar triangles, we can use ratios to help us. So we've got a ratio of 1.8 to 2.4 to a hypotenuse, and we don't know what that is. That's what we're trying to find. Maybe I can make it easier by multiplying them by 10 to get rid of those decimal points. 18, 24, and the hypotenuse. Let's simplify those down. Well, they're both in the 3 times table. They're both also in the 6 times table. So 18 divided by 6 is going to give me 3. 24 divided by 6 is going to give me 4. And look, how easy is that? I can use my knowledge of Pythagorean triples, 3, 4, 5 triangle. So I know that the hypotenuse of a 3, 4, 5 triangle is 5. But we've got to work back to work out what that is. So we know that here we multiplied by 10 and then we divided by 6. If we're coming back this other way, instead of dividing by 6, I need to multiply by 6. That means this hypotenuse here would be 30. And then finally, instead of multiplying by 10, I need to divide by 10. So this hypotenuse, let's use a different colour to make it a bit clearer for you to see. This hypotenuse is going to be 3 centimetres. Okay, so the answer to question 15 is A, 3 centimetres. Question 16. So we want the value of 1/9 plus 1/11. So a couple of different ways we can do this. Firstly, we can use equivalent fractions to add them together. So we could do 1/9 plus 1/11. We need a common denominator. We're going to use 99. So we've got 11/99 plus 9/99. That gives us 20/99. I then need to do a division calculation. I've got 20 and I'm dividing it by 99. 99 goes, well, it doesn't go into 20, but it goes into 200. 2 times remainder 2. It doesn't go into 20, goes into 200. 2 times remainder 2. Doesn't go into 20. You get the picture. So we have a recurring decimal of 0.20 with the 2 and the 0 recurring. That tells me that the answer to this question is E, 0.20 recurring. There is another way that you could do it, and some of you might even know these facts. They're really good ones to remember, actually. 1/9 is 0.11111 recurring, obviously. And that's probably quite an easy one to remember because you know that 1/3 is 0.3 recurring. So therefore 1/9 being 0.1 recurring, fairly straightforward. So if we know that 1/9 is 0.1 recurring, and if we knew that 1/11 was 0.0909, etc. recurring, if I add these two together, you're going to see that I'm going to get exactly that same pattern, 202020 recurring if I had the right number of digits there. And you can see again that your answer is going to be 0.20 recurring. So the answer to question 16 again is E. Question 17. Right, again, a couple of different ways of looking at this. Let's start with the knave of hearts. So we're going to do it 2 ways. We're going to work forwards and then we're going to work backwards. There is actually a third way that you could substitute in the answers. And by a process of elimination, work out which one is correct. And that's actually a great way to check your work as well. So the knave of hearts stole some hearts. He ate half of them and half a tart more. So we want to know how many he's got left because the knave of diamonds ate half of what was left. So if he ate half of them and half a tart more, and I'm going to say that the number that we started with was X, he ate half of them and half a tart more, then we're going to be left with 1 subtract half a tart and half a tart more, which is x/2 subtract half. So this is how much is left when it comes to the knave of diamonds. So what is the knave of diamonds going to do? He's going to eat half of what's left. So he's going to eat half of this, and then he's going to eat another half more. So what is left is 1 subtract that. So it's going to be half of this subtract 1/2. And this is how much comes to the knave of clubs. He is now going to eat half of all of that plus half of 1 more. So 1 subtract all of that is going to give us this subtract 1/2. Okay, and all of that together is what's left for the knave of spades, which is 1 tart. So all of that equals 1. So let's see what we need to do. Let's start by working with what's within the brackets. So we've got x/2 subtract 1/2. So let's just write that for now. Let's write it. So we've got x subtract 1/2. We want half of that. And then we're subtracting our half, and then we're subtracting half again. And that's going to give us 1. Okay, so half of x subtract 1 over 2 is going to be x subtract 1 over 4. And then we're subtracting another half. And then we're taking a half of it. And then there's no reason why we can't add that on there to make that 1.5. Okay, so now we could, we've got two choices. We could expand this, or we could actually divide both sides by 1/2. Up to you which way we do it. Let's try expanding this out. So let's see what we've got going on here. In fact, it might be easier just to split it back out again. So I've got x over 4, subtract 1/4, subtract 2/4 equals 1.5. So I've got x over 4, subtract 3/4 equals 1.5. Let's keep going. We're nearly there. Okay, so I've now expanding this. I've got x over 8, subtract 3 over 8 equals, maybe we can write that as an improper fraction now. That might help us. So if I look on this side, I've got x over 8. I'm adding 3/8 to both sides. So I've got 3 over 2 plus 3 over 8. I can rewrite this as 12 over 8 plus 3 over 8, which is going to give me 15 over 8. Whew, we're nearly there. X over 8, I've run out of space, equals 15 over 8. Therefore, multiplying both sides by 8 is going to give me x equals 15. So the answer is 15. Right, I said there was a couple of different ways of doing it. So if you can work backwards, you might find it a little bit easier. Let's see what happens if we work backwards. So if we start with the 1, which is what we're left with, we start with 1, and we're going to say that the knave of clubs, so let's use C for clubs, over 2, subtract 1/2 equals 1. That means C over 2 is 3 over 2, or 1.5, and C is therefore 3. So that's how many tarts. We need to go back now to the diamonds. So we know that D for diamonds over 2, subtract 1/2 equals 3. Again, if I add that half to both sides, D over 2 is going to be 3.5, or 7 over 2, and D is therefore 7. Okay, let's now go back to the knave of hearts. So we've got hearts over 2, subtract 1/2 equals 7. So we're adding 1/2 to both sides. We've got 7.5, or 15 over 2. So the knave of hearts started with, can you say that? Sorry. Started with 15 tarts. Finally, if you were using just a process of elimination and you just wanted to substitute, let's squish it down at the bottom here. So, or if you just want to check because you've got time at the end, then you've got 15, which is the number you started with, divided by 2 because he ate half of them, and then he ate another half. So he ate 16 over 2, he ate 8. That means there were 7 left. So we start with 7. He eats half of them and then half more. So he eats 4, which means that 7 subtract 4 means that there are only 3 left. Finally, we take the 3. We divide, can you still see? Divide by 2. We add a half. That gives us 4 over 2, which means he ate 2. 3 subtract 2 means that there is 1 left. So 3 different ways of getting to the solution. Question 17, the answer being E, and 15 tarts. Question 18. We know that the hypotenuse is y. We know it's a right angle triangle, and we know that it's made up of identical squares and congruent isosceles right angle triangles. So that tells us that this side length here and this side length here are the same. So I'm going to call them both x for now. I know using Pythagoras that x squared plus x squared equals y squared. So I can rearrange that. I know that 2x squared obviously equals y squared. X squared equals y squared over 2. So I can write that x is the square root of y squared over 2. All right. So that gives me this length here, x, in terms of y. I know that the area of the whole triangle, is going to be half multiplied by the base and the height. The base and the height obviously both being y squared over 2 square root of. I'm sure you can fast forward that and recognise that the square root of that multiplied by the square root of that is just going to give me 1/2 multiplied by y squared over 2. So that's going to give me y squared over 4. So that is the area of the triangle. If I want to know the area of the shaded area, if I just have a double quick look here, I've got 1, 2, 3, 4 squares shaded versus 1, 2, 3, 4 squares shaded. So I'm just looking for 50% of the area of the triangle. So the shaded area is half of y squared over 4, which gives me y squared over 8. So the answer to question 18 is C, y squared over 8. Question 19. I would suggest with a question like this, if you've got time, try and sketch it out yourself. So what I've done here, I'm just going to move it down so you can see, is at the moment I've just drawn my square, I've drawn the diagonals, and I've drawn the centre point of my circles. So hopefully what you can see now just by inspection is that if I did, and I'm not going to do a terribly good job, but if I did draw a semicircle here and I continued it round, whoops, hopefully you can, should have brought a compass, shouldn't I? You will see that you're going to end up with a circle of a radius let's have a look. So the overall length here is 48. So half of it is going to be 24, and therefore the radius of my circle is going to be 12. So hopefully by inspection you can see the way that's going to work, that when you've got your midpoint here of this line, and that's the center point of your circle, you're going to get exactly 4 radii that take you from one side of the square to the other, and therefore the answer to question 19 is B, 12. Question 20. I really like this question. For a question 20, I really don't think it's too bad at all. The first thing I'm going to do is I'm going to replace my 1/2, third, quarter with n. So I've got, let's use a different colour, x plus n and x minus n. Now we know when we expand that, I'm going to get x squared. I've got a plus nx, and then I'm going to subtract nx. They cancel out. So I'm going to end up with x squared subtract n squared. As soon as I've got that, I think I've pretty much got the answer, because I know that the largest value is when n is smallest. And I know that n is smallest when I square 1/4. If I'm not sure and I want to check, there's nothing to stop me writing out 1 squared is 1, 1/2 squared is 1/4, 1/3 squared is 1/9, and 1/4 squared is 1/16. Maybe just do that to be doubly clear. So the answer is D. This question looks a bit challenging because I've got to work out this section here. I know how to work out the area of my large semicircle and my 3 small semicircles, but this bit might be a little bit confusing to start with. So let's see if we can make it a bit easier. And let's just draw in 2 lines here. And hopefully you can see that now what I've done is I've created a rectangle that includes that funny shape in the middle. And I can see therefore that I've got 1, 2, 3, and if we call this whole rectangle here 4. So I can see that 1 and 2 and 3 together is going to create a whole circle. So 1 plus 2 plus 3 is my small circle. 4 is a rectangle. And then obviously I've got the semicircle of the large circle as well. All right, let's get started. So let's do my small circle first. So the area of my small circle is pi r squared, and I know that my small circle has a radius of 1. So I've got pi multiplied by 1 squared, which is obviously just pi. I've now got my rectangle. So the area of my rectangle, well, I've got obviously all those dimensions there are going to be 1. So the area of my rectangle is going to be 2 multiplied by 1, which is 2. So the total of the white area is pi plus 2. Right, let's do the area of the semicircle. So we've got the large semicircle. We know that that's going to be half of pi r squared. So what's our radius for our large semicircle? The radius is going to be 2, so pi multiplied by 2 squared. So I've got a half pi multiplied by 4. So the area of my large semicircle is, is 2 pi. Finally, to get my shaded area, I've got 2 pi, which is the area of my semicircle, and I need to subtract the total white area, which was pi plus 2. So I've got 2 pi, subtract pi, subtract positive 2, so I'm subtracting 2. So I've got pi subtract 2 as my answer. Let's go all the way back up to the top. And yes, indeed, that is B. Pi subtract 2 is the answer to question 21. Question 22. So you've got a couple of different ways of solving this. If I know that the interior angles of a pentagon sum to 540 degrees, I know that because it's n subtract 2 multiplied by 180. So 3 multiplied by 180 gives me 540. But most of you probably know that the sum of the interior angles of a pentagon of 540 degrees, I've got 5 interior angles. So each interior angle is 108 degrees. So there's my 108 degrees. Now, some of you might be able to go straight to the answer here. Some of you might say, okay, well then this angle here is going to be 360 subtract 108, which is going to give me 252 degrees. But the calculation that I needed to do was the sum of these three angles. I know that the sum of the four angles of my quadrilateral are 360. Therefore, the sum of my three angles here is going to be this 108 degrees. So the answer is C, 108 degrees. Now, there is another way that we can look at it. So that was using interior angles. We could have also used exterior angles. Now we know that the exterior angles sum to 360. We know that there are 5 angles, so therefore each angle is going to be 72 degrees. So if this is one side of my pentagon, this angle here is 72. Obviously this is 180. That tells me this total angle here is 252 degrees, which is this angle we've got here. And again, all I need to now do is 360 subtract my 252, and that is going to give me the sum of the three shaded angles, which is 108. Question 22, C, 108 degrees. Question 23. We have congruent triangles here. We know that each one is half a square, so that tells us that this is a right angle. It also tells us that these two side lengths are equal. So we're dealing with isosceles triangles. And if we make, I've just made them slightly larger down here to make it easier. If we make the side length A, let's say, here, we know that these are all A. What else have I got here? Okay, and now I've got these, which are the hypotenuse. So I just need to quickly calculate the hypotenuse. Well, I know that A squared plus A squared equals my hypotenuse. So my hypotenuse is the square root of 2A squared, or A root 2. So the hypotenuse is A root 2. And I know that root 2 is about, so let's say approximately equal to 1.4A. All right, that might be helpful. So let's have a look and see what we've got. And we're just going to call the hypotenuse H for now to make it easier. And let's see how we can compare our perimeters. So for P, I've got 2A plus 3H. For Q, I've got 6A plus H. And for R, oh no, you can't see, sorry again. Okay, for R, I've got 4A plus 3H. So I can see straight away that P is smaller than R, but I just need to check. So what I'm going to do is I'm just going to use approximation. I've got 2A, and I know that 3H is the same as about 1.4A. So I've got 3 lots of 1.4A. So that's going to be 4.2. So that's going to give me 6.2A approximately. Remember, we're just working it out approximately. I've got 6A here. I'm adding another one. So I'm adding 1.4A. That's going to give me 7.4A. And then finally here, I've got 4A, and I'm adding again my 4.2A here. That's going to give me my 8.2A. So we can see straight away the size. Let's go back to the question, because sometimes they'll ask for ascending, sometimes for descending. This time it's ascending, so we're doing smallest to largest. So we're going to have PQR as our solution. PQR, which is A. So the answer to question 23 is A. Question 24. So I've started by writing out the question. I know that 10 is 2 multiplied by 5, multiplied by 2 to the power n. I know I can also write 2 as 2 to the power 1 equals 2 to the power n plus 2 to the power n plus 2. So I can write that 2 to the power n multiplied by 2 to the power 2. Sorry, that's a 2. Right, let's see what happens now. So I've got 5 lots of 2 to the power of m plus 1. Okay, plus, made a bit of a mess of that, haven't I? 2 to the power n, and I've got 2 to the power n multiplied by 2 to the power 2, which is 4. So I've got 4 lots of 2 to the power n. So I've got 5 multiplied by 2 to the power m plus 1 equals 4 lots of 2 to the power n plus 1 lot of 2 to the power n gives me 5 lots of 2 to the power n. So I can divide both sides by 5. 2 to the power m plus 1 equals 2 to the power n. I can therefore say that m plus 1 equals n, and therefore the difference between m and n is 1. So the answer to question 24 is 1. This last question is a tough one, but let's see how we get on. So we know that these 6 points are equally spaced around the circumference. So I therefore know that I can split my circle into 6 equal sectors. Let's see how that helps us. Okay, so I've got 6 equal sectors here, and I know, let's see, not sure if it's useful yet, but let's write it down. I know that the angle of each of those sectors is therefore going to be 60 degrees. Now I know how to work out the area of the whole circle. That's fairly straightforward. Let's do that first. The whole circle area equals pi r squared. I'm told that the radius is 2 centimetres. So pi times 2 squared, my area is 4 pi. So if I know that the area is 4 pi, I know that one of my sectors, which is 1/6 of my circle, is going to be 1/6 of 4 pi. So one sector is 1/6 of 4 pi, which we can simplify down to 2/3 of pi, or 2 pi over 3. Okay, so we've got the whole sector, but we need to work out what this white bit is, don't we? Because if we can subtract this white bit 3 times, then we're going to have the whole shaded area. So we need to work out this bit here. So we know what the whole sector is. If we can work out what this arrowhead quadrilateral is here and subtract this from the whole sector, that's going to give us the area of the shaded part there. So let's see if we can draw this out to help us. Let's make a little bit more room. So I'm just going to draw the shape that we're dealing with. I always find if I can sketch things out, you see, it's not particularly to scale. I'm not even using a ruler. And I know that it's symmetrical. That might be useful as well. I also know that this whole angle here is 60 degrees, and therefore that is going to be 30 degrees. I know that this distance here is 2 centimetres. So I've got a 2 centimetres here and I've got a 2 centimetres there. I also know that this inner circle here has a radius of 1. So I know that this distance here is this distance here, and it is therefore 1 centimetre. I think I've got enough information now, but I'm just going to sketch it out again just to help me. So I'm just going to draw half of my quadrilateral. I'm going to draw the triangle at the bottom. Okay, so it's not totally accurate, but again, it doesn't have to be perfectly accurate. It's just representative. I've got a 30 degrees there. I've got a 2 centimetres there, and I've got a 1 centimetre here. To work out the area of this triangle, I need to know the perpendicular height, don't I? I need to know the perpendicular height, and I'm going to call that H. So I'm now just looking at the right angle triangle bit here, and I'm going to use my sine rule. I know that, can you see? You still see what I'm doing? I know that sine of 30 is my opposite. My opposite is my is H, sorry, apologies, H, over my hypotenuse, and my hypotenuse is 1. Therefore, I know that H equals sine 30. Now, this is important that I know that sine 30 is 1/2. Remember, I don't have a calculator for the UK Maths Challenge. H is 1/2. I think we're fairly close to solving this now. So I can work out the area of this triangle. So I'm just going to move across to this side. So the area of the triangle, okay, with a perpendicular height of 1/2 and a base of 2, the area of my triangle is 1/2 times base of 2 times perpendicular height. That's going to give me an area of 1/2 centimetre squared. Now remember, I want the area of my quadrilateral, my arrowhead. So that's going to be 2 triangles. So it's going to be 1/2 multiplied by 2, which gives me 1 centimetre squared. I think we're nearly there. Let's have a look at our drawing here. I'm trying to find this. I know that the sector is 2/3 of pi, and I know that this quadrilateral I've calculated is 1. So the area of my shaded shape, which was that bit there, is going to be the area of my sector, which is 2/3 pi, and then I need to subtract the area of my quadrilateral, which is 1. Now remember, I've got 3 of these, yeah? 1, 2, 3. So the area of 3 of those is 3 lots of 2/3 pi subtract 1. Okay, can you still see that just about? All right, so now we want the area which is shaded. So to finish off, we know that the whole circle is 4 pi. We worked that out right at the start, and now we want to subtract this. So let's expand it as we go. We've got 3 lots of 2/3 pi, so that's going to give me 6/3 pi. Okay, and then I've got 3 lots of -1. So I'm subtracting 3 lots of -1. So if I'm subtracting a negative, that's the same as adding a positive. I've left the bracket in. So let's leave that like that. So it's a -3 at the moment. So I've got a negative, I'm subtracting 2 pi subtract 3. So I've got 4, you can see that just squashed right at the bottom now. I've got 4 pi subtract 2 pi, but then I've got to add the 3. So I'm going to have 2 pi plus 3. Be careful with those negative numbers. It'd be awful, wouldn't it, to lose the mark after all that hard work. 2 pi plus 3. Let's go all the way back up to the top. That gives me the solution of A. Thank you very much. I know that is a tough question. I'll just make sure that you've seen all of that there. Thank you and good luck with the maths challenge.